Okay, as we continue on now, you'll notice that this one looks a little bit different than the other two examples. Notice that we have this 2k and this positive 3m that's outside of the parentheses. That means that that just carries down, and we're not going to do anything with that first. Order of operations, say parentheses first. Now obviously because we have a k and we have an m, they're not similar terms. We have no outside power, but notice this subtract sign, which again says for everything follows in the parenthesis that follows that subtract, you need to take the opposite sign. So the opposite sign of a positive 4k is a negative 4k, and again we're writing what we say. The opposite of a negative 2m is a positive 2m. We're writing what we say. Now notice that the parentheses at this point have closed for that one. So then we go to our next parenthesis to follow order of operations, and we can't combine the k with the m. There's no outside power as we check for exponents, but notice that there's a positive 2. And what we're going to do is we're going to distribute that positive 2 into the parentheses because we can't get a 1 result for k minus 4m. So we have to take and say that 2 is being multiplied to the k for a positive 2k, and that positive 2 is being multiplied to the negative 4m for a negative 8m. So once we get our results, we're now down to all addition or subtraction. So as we look at this particular example, what we're going to do is we're going to start off and say, all right, well I have 2k's, and then I have a negative 4k, and then I have another positive 2k's. So whether you go left to right here as you add or subtract coefficients, or if you say 2k's plus 2k's or 4k's, and 4k's take away 4k's, cancel my k's completely out, and it's okay for them to go away. The next one we see is a positive 3m. Added to that 2 more m's for 5 m's. And when we take the 5m and we subtract the 8m, ultimately our signs are different. This is positive and negative information again. So we're going to say 5m's take away 8m's, or we're going to go negative 8 and the positive 5. We're going to subtract the numbers, keep the sign of the larger absolute, and keep the variable base the same. I have a negative 3m left over for my final answer. Now in our guided practice, you'll notice it goes back to the beginning, so I'm going to talk us through this, but pause it if I'm moving too quickly through this and take time to solve the problems out. So we're going to look at our first parenthesis and ask, can I combine any similar terms inside? Remember, same base, same power. Then I'm going to check outside in the exponential position of my parentheses. And then I'm going to check in front to see if there's anything that's going to change the parenthesis. And if not, we're going to drop the parenthesis. Moving to the second parenthesis, we're going to look and say, can I combine any similar terms inside of that parenthesis? And again, remember, same base, same power. If you can't do anything inside, check and see if there's an outside exponent. And then you're going to come in front to see if there's anything directly in front attached to it that's going to change what's inside. Remember, if it's a plus, it says keep things the same, drop your parenthesis. Remember, if it's a subtract, it says take the opposite sign of every single term inside. As you drop your parenthesis, you write what you say the opposite sign is. And don't forget to add a 1 for any coefficient that you have no number shown. And then lastly, you're going to combine similar term. We're adding and subtracting the numbers in front, the coefficients only. So I say I have a y squared term. Are there any others? And then add or subtract the numbers in front. Then I have a y term. Are there any others? And if so, add or subtract the numbers in front, but keep the variable bases the same. And then lastly, do I have any constants that I can combine? All right, so let's look at this problem out. Again, notice that we start off with a y squared and a y, so we can't do anything with that. They are different powers, so you can't combine it. No outside exponent and nothing in front to change it, so we drop the parenthesis. In the second parenthesis, I'm going to add a 1, but we have a y squared and a y again, different powers, we can't combine it. No outside power, but notice that I have a subtract. That subtract says let's take the opposite sign of a positive 1y, which is a negative 1y squared. the opposite sign of a negative 4y, which is a positive 4y, the opposite sign of a positive 6, which is a negative 6. And notice again, I'm dropping the parentheses as I write that. Now we're down to just addition or subtraction. So I say, okay, my first term is a y squared. I have 5 here. Do I have any other y squared terms? And in fact, I have a take away 1. So 5 y squareds take away one of those y squareds, leave you with 4 y squared terms. Moving to my y's, 3 y's here and a positive 4y gives you a total of 7 y's. And then again, the constant just comes down and joins our end answer. Let's look at our next example. As we look at these problems again, check and say, can I merge the two in the parentheses? If they're different, do I have an outside power? And then look in front. Is there something that you can distribute in? And if so, take that action. Make sure you go all the way through the parentheses until from where they start to where they stop, taking something outside and distributing it through. Then move to the second parentheses. Can I combine similar terms? Is there an outside power? Is there anything stuck to the parenthesis in front that's going to change what's inside? And if so, take that action. And then the last thing we're going to do now that we're down to addition or subtraction, you should see no more parentheses, is you're going to combine similar terms. So start with your first term and say, do I have any more that look like that in my polynomial? And if so, changing the numbers only in front, keep the variable base the same. And then do the same with your constant terms, and you're done your problem. So let's look at this example. I can't combine x with the 1/2. There's no outside power, but in front there is an 8 that's being multiplied to that parenthesis. So just like we distributed before, we're going to go 8 times x and say that's 8x. Then I have to distribute that all the way through, so 8, which I'm going to write as a fraction, times 1/2 gives me 8 over 2, or half of 8, which is 4. Now notice that that 1/2 is negative, so that means my answer is a negative 4. Now I move to the second parenthesis, and as I look at this second parenthesis, I have an x and a number I can't combine. No outside power, and then I look in front and say it's a negative. I'm going to add the 1 here so that I say the opposite of a positive 1x is a negative 1x, and the opposite of a negative 4 is a positive 4. So now we're down to combine similar terms. 8x's take away 1x is 7x, and notice that the 4's are opposites of each other and they cancel completely out. So our final end answer is 7x's. All right, in our self-check, remember to pause the video at this point in time, try the problem yourself, and then compare your answer with mine. To start this problem, the first thing I'm going to do is add a 1 because there is no coefficient shown at that first part, and notice that there's no parentheses there, so that actually is going to come down as our next step. The first thing that we're going to do is we're going to take care of our parenthesis. I have an m squared and a constant. I can't combine those two terms together. No outside power. But in front I have this positive 4, so again we're going to distribute it through. 4 times m squared and 4 times a negative 1. And we're going to drop the parentheses as you write the results of these. So 4 times m squared is a positive 4m squared. 4 times negative 1 is a negative 4. Now notice that the parenthesis closes, and then outside of it to the right I have this plus 3, which is just going to come down as part of our answer. Now we're down to combine similar terms. 1m squared plus 4 more m squareds gives me 5 of the m squared terms. Don't change the power. Negative 4 and a positive 3, signs are different, so we're going to subtract and then keep the sign of the larger absolute. So my final answer is 5m squared minus 1. And our last example, do the same thing. Pause the video, try the problem yourself, and then check my answer to yours when you're done. First thing we're going to notice here is we have an x and we have a y. Different variable bases, we can't combine them. No outside power, but in front we have a 5. So we're going to distribute that 5. It's 5 times x and 5 times a positive y. Always remembering that the sign of a term is in front of it. So that gives me a positive 5x and a positive 5y. Moving to our next parenthesis, I have an x and a y, but no outside power. So I look in front and it's a 2. So 2 times x is our first distribution that we take. And that gives me a positive 2x. And then that 2 also goes to the negative 1y. And I'll show that 1 there just as a visual. So 2 times a negative 1 is a negative 2y. Then outside of the parentheses, there's this 10xy term. And I want you to notice that this xy term is joined through multiplication. And because of that, it's one term, it's one monomial term, but it doesn't match any of the other terms. So it's going to just carry down through as part of my answer. So to set this up to combine similar terms, 5x's plus 2 more gives me 7x's. Positive 5y take away 2y is a positive 3y. And then this just comes down and tacks on at the last part of my answer for my final answer. All right, this concludes the adding and subtracting portion of our video, the second part. So make sure that you go through these and you're prepared for discussion in the next class that we have.